Hello ladies and gentlemen, I hope everyone is doing well today. Welcome to another chemquest, this time covering electron configurations and the periodic table. In this chemquest we're going to be combining a few things from the previous chemquests. So we are going to be combining what we learned about electron configurations 2 chemquests ago with what we learned about valence electrons in the last chemquest. So right up top we have some information. The unhighlighted part is a little bit of what I just said. What I highlighted, guys, really important is a little vocabulary. Remember, rows on the periodic table, they go horizontally from left to right, and we call those periods. Remember, columns, they're vertical, they go up and down. They can also be called groups. So question one, we start off by wanting to draw some electron configurations for lithium, sodium, and potassium. That way we can compare and contrast, and we can learn some information about the periodic table, the way it's arranged, and how it can help us with electron configurations. It is worth noting, guys, on our periodic table, lithium, sodium, and potassium are all found in the first column. So, I have a little bit of information written down for us. This is information that we find in the various chemquests throughout the year, or throughout the unit, sorry. So this first information is from electron configuration. It's your long list of energy levels and sub-levels. So that information is found right up here. This information right below, so this is found from an electron's address. It's how we calculate the number of electrons in each sub-level. So remember, in an S sub-level we have one orbital. Each orbital, doesn't matter which kind of sub-level you're in, has 2 electrons. Then we can multiply the number of orbitals by the number of electrons that fit in each orbital to find the total number of electrons that fit in that sublevel. So that's why in the s orbital we have 2 electrons. In the p orbital we have 6 electrons. In the d sublevel we have 10 electrons. And in an f sublevel we have 14. So I'm going to use this information so that I don't have to keep flipping back and forth. It would be in your best interest to write this down too. That way you don't have to keep flipping back and forth as well. You will be using this a lot in this chemquest, so it will be helpful. So question 1, I'm going to help you guys. We're going to do questions 1, 2, and 3 together, and then you can base some of the other questions off what we do here. So question 1. We're going to start by drawing electron configurations for lithium, sodium, and potassium. So what we need to know are the number of electrons that they have. So lithium has 3 electrons, sodium has 11, and potassium has 19. So I'm going to do lithium right here. I'm going to do sodium underneath it, and then potassium on the bottom. So remember, guys, this list goes from low energy to high energy. We need to fill in the left side, the left side before we can fill in the right side. So if we're starting with lithium, we can start with 1s. Remember, S can hold 2 electrons, so we write a 2. Then we subtract 2 from 3, we have 1 left. After 1s comes 2s, so we write 2s. We put a 1 because there's only 1 left, so we have 0. We do the same thing for sodium. We start with 1s, we can put a 2, so then that becomes 9. Then we can do a 2s. Again, we can hold 2, so we write a 2. So that goes to 7. After 2s comes 2p, so we write a 2p. P's can hold 6 electrons, so we write a 6. And then we have 1 left. After 2p comes 3s, so we write 3s, and we put a 1. Now we have 0 left, so now we know we're done. Next we can do the same thing for potassium. So potassium, we're starting with 1s, like 2 electrons, so we go to 17. Then we have 2s, again 2 electrons, so we go to 15. After 2s comes 2p. We can put 6, so we put a 6, and then we go to 9. After 2p comes 3s, so we can put a 3s, and we can put a 2, and then we have 7. After 3s comes 3p. P's can still hold 6, so we write 6. And there's 1, and then lastly, after 3p comes 4s. We only have a 1, so we put 1 left. So now we can do question 2. We can use these electron configurations to answer the next few questions. So it wants us to figure out what's similar about these electron configurations by looking at the end. So this is the part, the ending, the valence electrons. This is where we're going to be looking. So what we notice about everything at the end is they all end in different energy levels, but they all can end in the same sublevel with the same number of electrons. So they end in the same sublevel with the same number of electrons. Next we can move on to question 3. So question 3 is asking us to analyze using the periodic table. It tells us that lithium is in row 2, sodium is in row 3, potassium is in row 4. So now it wants us to again analyze it in regards to the ending of the electron configuration. So what hopefully you notice is that the energy level that it ends in is also the row. So look, lithium ends in the second energy level and it's in row 1, 2. Sodium ends in the third energy level and it's in row 3, 1, 2, 3. Potassium ends in row 4 and it's row 1, 2, 3, 4. So what we see here is that the row they end in, the row number, equals the energy level it ends in. So next what you guys can do is you can do 4, 5, and 6, really similar to how I did 1, 2, and 3. When you're answering 5 and 6, use what we wrote up here to help you. Do you notice something similar? Next, question 7. So question 7 is going to be drawing a conclusion. So you're going to use what we did in 1, 2, 3, 4, 5, and 6 and answer this question. What you need to remember, guys, is columns. Remember, columns go up and down. So remember, everything was in the same column. What do you notice? So pause the video and think about this now. So next, question 8. We're going to move on to question 8. So when you're thinking about question 8, hopefully you realized that column 1 ends in S1 and column 2 ends in S2. So that's something we can add up top. So column 1 on PTE equals S1. Column 2 on the PTE equals S2. We can also combine what we learned in question 3 and question 6, that the energy level tells us the period or the row. We can use that, and now we can use the periodic table to identify different elements. So I'm going to help you with the first few. So we can start with number 8. So we're starting with 5s1. So let's analyze what this means. So remember, this 5, it tells you this information right here. Let's highlight it. The energy level equals the period or the row. So we can come over here, use our periodic table. We're looking at 5s1. So we know 5, row 5, so 1, 2, 3, 4, 5. And then remember, S1 tells us that it's in column 1. So this right here, this is the element rubidium. You can use the symbols here, you don't have to write it out. Rb. Next, we can do the same thing for 6s2. So remember, the energy level tells us the row, and then S2 tells us it's in column 2. So let's count down. 1, 2, 3, 4, 5, 6. And then S2 tells us column 2. So it's barium. Now, I'd like you to do 8C. So this next page, 9 through 17. 9 through 17 is exactly what we just did in 1 through 8, except this time you're going to be analyzing different columns on the periodic table. Some columns will be over here, some columns will be over here. Yeah, so use what I did in questions 1 through 8 to help you model it the same way. Next, question 18. Question 18. So guys, hopefully what you found when you were working on up to question 17. Hopefully what you guys found out, we already learned in the first few that S columns are columns 1 and 2. Hopefully you realize that all of the elements, all of the atoms that are going to end in D, so the D block columns, they're located 3 through 12. And then the P block columns are located 13 through 18. Also, guys, hopefully you realize that we can use different trends on the periodic table to be able to quickly identify elements, just like we did in question 8. So what we can do is we can label our periodic table. This is something you can write on here, something that will be helpful when you are working on the next few problems and on tests and quizzes. You'll be allowed to use this on your test and quiz as long as you don't write any extra stuff. So we have this information for econfigs. So we know that this column ends in S1. Column 2 ends in S2. Then we can go, remember, after S comes P. So we'll move over here. Column 13, everything in this column ends in P1. Everything in 14, P2. 15, P3. 16, P4. 17, P5. And 18, P6. Next we can fill in the D block. It's the same trend. Starting on the left it goes D1 and then it increases by 1 all the way to D10. So column 3, D1, D2, D3, D4, D5, D6, D7, D8, D9, and D10. So we can use this to help us answer different questions. Watch, we'll use these in the next section when we abbreviate electron configurations. So electron configurations, they can be shortened using the noble gases. Remember, guys, noble gases are found in this column 18, right over here, all the way on the right. Remember, guys, these gases are very, very non-reactive. The reason why they aren't reactive is because their P energy level is full. Because it's full, they don't really have any electrons for bonding, but that's another story. We'll get there later. Just know that they're non-reactive, and we can use this to our advantage to help us shorten electron configurations. One thing that is worth noting, guys, we see on our periodic table that column 18, they end in P6. One other thing worth remembering is that the rho equals the energy level. This way we can quickly find different elements. So we're going to start with the element krypton. So krypton is a noble gas. It has atomic number 36, and it's found right over here. We wrote out krypton's electron configuration all the way out. One thing, so next we can compare krypton's electron configuration to strontium's. Strontium has an atomic number of 38. It's found over here. So if we compare strontium's electron configuration, which is found in the paragraph right here, to krypton's, which is found above, we notice that the only difference is this 5s2 right there. The only difference is because it has 2 more electrons. So we can use krypton's electron configuration to abbreviate. So this whole information, this whole section up here, that's krypton. So instead of writing all that out, we write krypton, and then we would write the 5s2. So watch, let me show you a little bit on how we can do that, a few steps we can follow. So down here, whoops, scrolled up too far. So right down here, we have another example of iodine. I didn't want to highlight everything, so I just put highlighted stars around it. Know that this is important, know that this is one of our examples. So we can start, we start with iodine, right down here. So the first step, so we find iodine on our periodic table, right here. Then what you do is you go backwards and find the previous noble gas. So remember, the previous noble gas will be the noble gas that is in the row in before it. So with iodine, we have to trace it all the way back to krypton. So we know that up to here, up to krypton, krypton and iodine are going to have the exact same electron configuration. So then what we do is we write krypton. We put Kr in brackets right there. Then we need to just find the missing electrons. We know that krypton is in the P6 column. It's in row 4. So it's going to end with 4p6, just like we see up here. It ends with 4p6. So that means when we come over here to rubidium, we need to start with 5s2. And then all we need to do is fill in the electrons in between, rubidium and iodine. So that's what you see right after the krypton, right up here. You see the missing electrons. You see that iodine has 17 more electrons. The reason why iodine has 17 more electrons is because 53 minus 36 equals 17. Remember, these are the atomic numbers. So we just need to fill in the missing electrons. So then we just fill in the missing 17 electrons. We pick up our list. Remember, guys, I said this would be important. So then we start with 4p. So 4p is right here. So then we started with 5s. So we had 17 electrons. So we start with 5s. S can hold 2. So we go to 15. Then after 5s comes 4d. 4d, we put in 10. So we don't go to 10, we go to 5. Then 5p. 5p can hold 6, but we only have 5 left, so we put a 5. Then that is the abbreviation for iodine. Down below there are a few more examples that you can check out if you want. But over here, I want to help you guys. I want to get you started with 19. I'm going to walk you guys through 19A. Then you guys can do B and C. So over here, I have a few steps. They are the same steps that you found up here. I just made them a little bit more generic, not looking at the scope of iodine. So the first step is you're going to go backwards on the periodic table and find the noble gas. So we can do that right now. So we're going to find ruthenium. Ruthenium is over here, number 44. Oops, ruthenium right there, atomic number 44. So you know what, I guess to help you guys, I can give you all the atomic numbers. Arsenic is right there, number 33. And then tellurium, Te is right there, number 52. So the first step, we're going to start with ruthenium, and we're going to go back on the periodic table to find the previous noble gas. So ruthenium is right here. Trace our way back, so we go back to krypton. So we start the same way. We will put, well, not the same way, but instead we put our krypton in brackets. Then we need to take note of that electron's noble gas. So we know that krypton is going to end in P6, and then it's going to end in which energy level? 1, 2, 3, 4. It ends in 4p6. So I make a little note, 4p6 on the side, because I know that you need to start with the sublevel that comes after. So we're starting with a sublevel that comes after 4p6. So if we look at our list, which we find right here, after 4p would come 5s. So then we know we're going to start with 5s. But first we need to figure out how many electrons we need to fill in. What's the difference between ruthenium and krypton? So to do that, we look at ruthenium, 44. We looked at krypton, 36. So then what we need to remember is 44 minus 36 equals 8 electrons. So we have 8 electrons to fill in. So after 5s, we can put a 2, because s holds 2. Then we have 6. After 5s comes 4d. D's can hold 10, but we only have 6 left. So we write a 6. That gives us 0. Now we're done. That is the abbreviated electron configuration for ruthenium. So now guys, I want you to do the same thing for 19B and C. Use these steps on the side. Use how I modeled the 19A, and use your periodic table. Remember guys, get your get your Electron configuration shortcuts. Make sure you write them in here. Make sure you use them to help you. Like always, guys, I will try to end these with a joke. Why do stadiums get hot after the game? It's because all of the fans left. I hope everyone has a wonderful day. I'll see you next class. Bye.